All right, we're going to talk more about triangles today. We've already covered some of the things that some of the things we'll talk about today will be reviewed, but we'll learn a few new things. So, first thing we're going to do is talk about classifying triangles by their side lengths. And so, triangles can come in three different forms when it comes to their side lengths. So I'm going to start over here on the right side. First of all, it can have no sides that are the same length. So if it has no little lines, telling you if it has a line like that on each one, that would tell you that those two are considered the same length. And but since this one has no lines cutting across any of the sides, it tells you there are no relationships between the lines, and we call that a scalene triangle. Scalene just means all the sides are different length. This one has these two lines across two of the sides. That tells us that two of the sides are of equal length. And when you have a triangle with two sides of equal length, we call that isosceles. Isosceles, one of the more fun words we get to say in math, although one of the harder words to spell. Isosceles. See, isn't that fun? Okay. And then you can have a triangle that has three sides that are equal, and we call that an equilateral. That one kind of makes the most sense, right? Equilateral sounds like equal. All right, so that's classifying triangles by side length. We also can classify triangles according to their angles. An equilateral triangle will always have three equal sides, but it will also have three equal angles. So equilateral means equal sides, but it also means equal angles. An acute triangle means that all three angles are less than 90 degrees. And a right triangle means that one angle is 90 degrees. And the word obtuse means that it has one angle greater than 90 degrees. So we can put those two things together, and we can have things like right scalene triangles or isosceles obtuse triangles or things like that. So part of what you'll do today is just classify triangles. Are they acute? Are they scalene? Are they equilateral? What are they? So some of what we're going to do today will require us maybe to make some estimates about some angles. We're not going to worry about measuring angles on the triangles here. We're just going to take our best stab at it. Most of them should be pretty obvious. In this case, this triangle, it's marked that those three angles are all equal. So if the three angles are equal, what does that tell you about the sides? The sides have to be equal as well. Even though they're not marked as such, they have to be, since all three angles are equal. And so with equilateral, we just have to name it, we just have to give it not one name, equilateral.
So you don't have to say equal angular, equilateral?
No, just equilateral. That's all we have to do. The rest, everything, all the properties of what it means to be an equilateral triangle are tied up in that word, equilateral. So we don't have to call it equilateral acute or anything else. Okay, what about this next angle? What does this little square here mean for us? It's a right triangle, and so it is right. And then what do these two little lines tell us?
Isosceles.
That it's isosceles. So it is a right isosceles triangle.
Oh,
ISOSCELES. All right, these two little angular marks here tell us what?
that those two are equal?
Those two angles are equal. And if the angles are equal, then the sides that are across from those angles have to be equal. Equal angles make equal sides in triangles. Okay, so that one would be
acute isosceles.
acute isosceles, because all of those angles definitely appear to be less than 90 degrees. So acute isosceles. What about this one where they're all three marked different? They're not the same.
Scalene.
Scalene.
Scalene. Is it just scalene?
Nope, we need to mark. What about the angles? Oh, does this look like a right angle?
Is it obtuse?
It's obtuse. Okay, that would be obtuse. That definitely is greater than 90 degrees. Scalene obtuse.
Okay, so for isosceles, you put it after the acute. And
I'm not worried about order. Order, you can call it obtuse scalene or scalene obtuse. You could call this one isosceles acute or acute isosceles. Order doesn't matter as long as you get both words in there. Okay. What about this one? It's definitely right. Then since all three angles are different, what does that tell you about all three sides? They're definitely different. So it's scalene. This one has two equal angles. Isosceles obtuse. I like it. That angle definitely appears to me to be greater than 90. All right, what about this one?
equilateral.
No, not equilateral.
Acute.
Isosceles acute. Yep. So they're definitely less than 6 or less than 90, but two sides are equal, one side is different. So that's isosceles acute. And then 1, 2, 3. Acute scalene. Good. All right. We also can find the missing value, and then once we know all three angles, then we can classify the triangle. So for this first one, if I just do 180 minus 38 minus 30, and I type that straight into my calculator, 138
112.
minus 38 minus 30. Why did I put 138? Wow. 180.
It should be 112.
180 minus 1, no. Struggling, sorry, minus 38 minus 30 is 112. Thank you. All right. Goodness. Forgot how calculator worked there for a second. So that means B equals 112. So what kind of triangle do we have?
Scalene obtuse.
Scalene obtuse. Now I can't spell scalene. I seem to have broken myself here. Scalene obtuse. All right, what about this next one?
45.
Yeah, 180 minus 90 minus 45 would give us 45. So B equals 45. What kind of triangle?
Right.
Right isosceles. A right isosceles triangle will always be 90, 45, 45. If these two are 60, what's this last one have to be?
60.
Also, it has to be 60. So that would be a 60, which means we've got equilateral. Equilaterals are all 360 60 degrees. All right, what's 180 minus 46 minus 45?
Right to up.
89.
B equals 89, okay? Which means we've got
And
scalene
Acute.
acute,
Oh.
less than 90. And then
Can you have a right angle where the other two aren't 45?
you can, but it can't be right isosceles. It would be right scalene. 180 minus 53 minus 34.
93.
93. So B is 93. That would be
Scaling.
scalene obtuse. Okay. That is the majority of what you're going to be required to do today on your assignment. There are a couple other little problems that I want to talk about as well. Sometimes you'll see a shape like this, and we have enough information here to be able to figure out the measures of angle 1, angle 2, and angle Y. I don't know why they number 1, 2, and Y. I don't know why it's that way, but whatever. So which one can I figure out for sure first?
The one.
Yeah, angle 1. For sure can figure out angle 1. So angle 1 would be 180 minus 19 minus 40. Is that 41? 41 equals 120. So angle 1 is 120. Now I've got two angles on this triangle that I need to figure out. Is there enough information to be able to figure out what those two are? I'm going to go with yes, there is enough information. Way back last week, I think it was probably Monday, we talked about two lines that cross each other like this, and we named these angles. Do you remember what angles 1 and 3 were called? Vertical angles. And what do you know is true about vertical angles?
You're equal.
They're equal. So if I have two lines crossing, just like that, then 1 and 2 are vertical angles. They have to be equal. So what is angle 2? Angle 2 has to be 120. Okay? And so now I can figure out angle Y. Angle Y is 180 minus 120 minus 38. 22? So Y is 22 degrees. Okay? I like problems like this that make you think a couple of steps down the road to figure out what you're supposed to do, kind of like this one. If I want to know the measure of angle S, there is enough information here given. We're only given one angle, but we know some other things about these triangles. So if I know angle P is 56, what other angle can I figure out first? YQ. Yeah, because P and Q are not vertical angles, but this line and this line tell me that this is an isosceles triangle. Isosceles triangles have two equal sides, but they also have two equal angles. And so if this 56-degree angle makes this line, and this line is the same length, then this angle has to be what? Has to be 56 degrees. So now I can figure out angle R, this one right here, 180 minus 56 minus 56.
68.
You said that like it was a question.
I'm pretty sure it's 68.
It's 68.
68. All right. I just wanted you to be sure. So now we know this one is 68. So if this one is 68, which other one can we figure out?
T.
T, because this 68-degree angle makes this side, right? So in order to make this side the same length, how big does T need to be? It has to be 68. So 180 minus 68 minus 68 equals 44. So S has to be 44. All right? I like problems like that make you figure out two or three things in a row to get down to the end where you want it to be. Which is kind of like this one. I know this one's not in your notes. I didn't want to print double-sided. For one more problem. This is the last one we're going to look at. So the measures of the angles of a triangle are in the ratio of 5, 6, 9. What is the measurement of each angle? So if you have this triangle, and I don't know if this is good or not, but it's going to be good enough. And what do I know all three angles have to add up to be? 180. And I know they're in the ratio of 5, 6, 9. Well, that one could be 5x, and this one would be 6x, and that one would be 9x. So I know those three angles have to add up to be 180 degrees. So now what?
You can add x's together.
Yeah, how many x's do I have here?
20.
Did somebody just say 3?
What was Bob?
5x plus 6x plus 9x. 5 plus 6 plus 9 is 20. 20x equals 180. All right. Technically you're right. There are 1, 2, 3 x's, but that's not the way math works. All right. It's not the way algebra goes here. So 20x equals 180. Divide by 20. This is just simple equation solving. Now at this point, x equals 9. So is that all I need to do?
Yeah.
No, it says what are the measures of the angles? What is the measure of each angle? So, yeah, 5 times 9 is 45. 6 times 9 is 54. And 9 times 9 is 81. Okay, so those are the measures of the angles. Guess what you get if you add up 45, 54, and 81?
Acute scale.
180.
It's 180 degrees, and it is an acute scalene triangle. All right, that's all for the notes for today. Let me hand out your assignment. Stop.